This is our first trinomial factoring video on perfect square trinomials. Let's get started. Okay, so today we are going to learn our first method for three-term polynomials. In order to do this, you should already know how to take out your GCF, which it's a given at this point, but you should also be able to rewrite terms as perfect squares. Example 1 is review. I need to expand 3p plus 4s squared and 2p minus 5s squared. Pause and restart the video when you're ready to go through the answer. I'll give it a go. Okay. 3p plus 4s squared is 9p squared plus 24ps plus 16s squared, and 2p minus 5s squared is 4p squared minus 20ps plus 25s squared. Do you see any patterns? Okay, well the first one is we always square the first term. 9p squared is the quantity 3p squared. 4p squared, quantity 2p squared. Second is that our second term is double the product of the unsquared first and last terms. So 3p times 4s times 2, and then 2p times negative 5s times 2. And the third is we always square the final term. We can use this because this pattern applies to all perfect square trinomials, which are the result of squaring a binomial. We'll use this to help us quickly factor trinomials of a certain kind. So let's take a minute and write out our pattern. We can use this to generalize a pattern when factoring a perfect square trinomial. The trinomial a squared plus 2ab plus b squared is equal to the quantity a plus b squared, and a squared minus 2ab plus b squared is equal to the quantity a minus b squared. So you'll probably notice that for both factoring patterns, both my first and my last terms are perfect squares. And my middle term is 2 times the unsquared product of my first and last term. And so we can use this to check if it's a perfect square trinomial before we apply this factoring method. The other thing to note is that the first sign of my trinomial is the same sign as my binomial. We'll use this to choose the right formula. Let's try an example together. 121 s squared minus 66 st plus 9t squared. I check for my GCF. Since I don't have one, I'll check to make sure that this is a perfect square trinomial. 121s squared is 11s squared. 9t squared is 3t squared, and my middle term is 2 times 11s times 3t. Checks out, perfect square trinomial. The next thing I do is I just rewrite my first and my last terms as perfect squares. I choose my factoring, my formula, and I drop my numbers in. It's really simple once you identify that it is a perfect square trinomial. Let's try another one. r to the 6th plus 8r cubed s squared plus 16x to the 4th. No GCF. Our first term is a perfect square. Our last term is a perfect square. And our middle term is the product of the two unsquared terms times 2. So this is a perfect square trinomial. I'm going to rewrite my first and last terms. Okay, and if you're able to skip that step, that's great. I just like to leave it in to make sure everybody's on the same page. I'm going to choose my formula. Okay, my first sign is a positive sign, so my binomial is addition, and then I'm going to drop in r to the 3rd and 4s squared. And that's it. We need to factor 3x to the 13th minus 18x to the 7th, y to the 5th, plus 27xy to the 10th. This polynomial actually has a GCF of 3x, so I'm going to go ahead and take that out first, and then I'm going to focus on if this is a perfect square trinomial. So my first term checks out, my last term checks out, my middle term checks out. So now we're just going to rewrite just the part inside the parentheses. Keep in mind, you may want to skip this step, totally fine. Now I'm going to choose my formula. I have my first sign is a minus sign, so I'm going to have a minus sign in my binomial. Keep that 3x out because we already factored it. We're going to drop the x to the 6th in and 3y to the 5th in. I need to factor 81p to the 8th plus 48p to the 4th, q to the 3rd plus 4q to the 6th. No GCF here. I'm going to check my requirements for a perfect square trinomial. My first term looks great. My second term looks great. My third term, oh, no, not 48. It should be 36. So unfortunately, our middle term doesn't fit and we cannot use the perfect square trinomial method. All right, so you now know one wonderful method to factor a trinomial. We are going to learn some more methods in the next couple of videos. Just keep in mind that this one only applies to a certain kind of trinomial and is not always applicable. We're going to check to make sure it's a perfect square trinomial. Then we rewrite our first and last terms as squares, optional step, and then finally we apply the correct formula. Next up, factoring using the AC method. I'll see you then.